current projects that you're working on?
Most of my work these days, like as in right now, I've got 4 or 5 things going on that are related to damage detection in structures rather than designing structures. But that's a cool area too. So I feel like I'm doing a job now, it's more like detective, where we put sensors on the structure, and then from the data we get off the structure, can we determine whether there's damage somewhere in the structure. We're designing the same material that the Boeing Dreamliner's made out of. They want us to test, this is now the Navy, nothing to do with Boeing, but it's the same material. The Navy wants to know if you can build sensors that can actually go inside the material. So this is really cool because we actually put sensors, little optical sensors, inside the material as the material is being made. So you can measure inside. So it's kind of like a smart structure. It has its own internal sensors. And what we were doing was we were qualifying those structures to see if they could withstand an underwater explosion. So I actually got to go to some quarries. They have some old mining quarries in Virginia that the Navy uses, and they blow things up in the water, and then you get to see if the blast waves, how they interact with your test specimen. So I'm happy so far that all of our sensors survive all of the shots. But it's pretty cool to watch this big bubble of water come out of the quarry, and you hear this big noise, and we get to see cameras underwater, and you can actually see the shock waves propagating through the water.
We got a paper, and it said you hold 4 patents. Can you tell us what they are?
4 patents are, all 3 of them are in the area of fiber optic sensors. So we designed 3 different designs of fiber optic sensors that can be used to measure temperature, pressures, stress in different applications. Probably the one I'm most proud of that's actually used in the real world often is one that is used at the bottom of oil wells to measure the pressure. So these are sensors that go, way deep down in the ground, and they help people, the engineers on the rigs, monitor the pressure down there to know how the drilling process is going. So that's pretty cool. The 4th one that's not an optical sensors is in a method. It's just an algorithm, if you will, a software, to be able to measure the arbitrary shape of very long, thin objects from limited distributed measurements internally of strain. And that's a little bit of a vague thing. It's kind of hard to explain, but it's essentially a measurement algorithm of how you can determine what the shape of something is by just measuring a few points along it in complex 3D. So think of a piece of spaghetti all twisted up on itself. How do you actually measure that shape if you just have a few sensors attached to it that don't directly measure shape? And that's what we came up with, was an algorithm to do that. Do you guys ever build anything in any of your classes?
We have this one woodshop class where we made cars with CO2 cartridges.
Oh yes, I remember like Pinewood Derby stuff when I was a kid. Similar, I guess. You can make cars and shoot them with CO2 canisters. That's really good. So, of course, what do you think is the primary objective in how you should design those cars? What do you want to make them do? Probably go as fast as possible, right? Yeah. So what do you think you need to do to the shape of the car in your design to make it as fast as possible?
Make it thin and aerodynamic.
Bingo! Make it aerodynamic. That's right.